So at this point you might be asking yourself, what the hell did I just do here? Let's just save this, and I want to talk about these attributes that I mentioned. So one way of displaying what our program does here is this, our viewport, the most useful and intuitive way of displaying 3D data. However, there's also a tab up here called Geometry Spreadsheet, and when I highlight this and highlight a given node, I can see the data that we're generating using this program here. And in our case, we are generating a bunch of points, and they only have their position in X, Y, and Z. And by a bunch of points, I mean many. But also, we are generating primitives, and also, those are quite a lot. And primitives in our case are those individual triangles, those polygons here. So back to the geo spreadsheet. And to define primitives, a primitive needs to have vertices, which we can display here. And also, the whole geometry stream as such has detail attributes. In this case, it has none, but the whole geometry can have attributes on itself. Another way of displaying a rough info about these attributes is to middle mouse on a node, which displays this here, or to just hover over a node and hit the info button here. So you can see we've got around 44,000 points, 88,000 primitives, 264,000 vertices, and 88,000 something polygons in here. And we've got one point attribute called P, which is the position. So this is Houdini's help file to illustrate a bit further what we're talking about here. When we're working with geometry data, this is the data we're typically working with. And this data stream can store individual values in different places. So it can store values on the detail, which is a single value per attribute for the whole data stream. Then it can have primitives and primitive attributes, and those primitives onto which we store those primitive attributes typically are something like polygons, polylines, or NURBS. And those primitives are typically defined by assigning vertices to a primitive, which are these purple triangles here. And those vertices, in this case, define which points make up a given polygon. And finally, we have those points, which are positions in space, and they can also store data on themselves. And Houdini having points and vertices is something that can be confusing when you're coming from other software tools. But it's important to understand what's the difference between those two. So a vertex, in this case, is a data structure that assigns a point to the corner of a polygon here. An analogy would be this. This triangular solar sail here would be our polygon, and those pillars here, at least the top of those pillars here, would be the points in space. Those holes, or those strings, that attach the sail to those pillars here are the vertices. So one pillar can have multiple sails attached to it. For example, it could have another sail attached on this side. And that's exactly the same as points and vertices work in Houdini. So a single point can be used to specify multiple polygons, just by assigning it to a given polygon using vertices. And when we highlight this part of the geometry stream and go to our point display here, you can see not only do our points have their position in X, Y, and Z, but they also now have a value called P-scale. An attribute called P-scale, which has a float value ranging from about 1.5 as its biggest and 0.33 as its lowest value, which we set up with this attribute randomize here. So when we select the geostream before that, we can see the points do not have that P-scale attribute, and after they do have that. Why did I call it P-scale, and where did I know that from to call it P-scale, to influence the scale of the spheres that we're generating? Well, there's a list with what's called template point attributes. And if you use an attribute with a name on that list, copy to points here will take care of using that attribute to do something. For example, to scale, to orient, or to color your individual copies, which is something that we want to do in the next tutorial when we are going to render out this image. If you guys like what we're doing and want to support us, you might want to head over to our Patreon, and we'd like to thank all of our patrons, especially Refik Anadol, Chris Hebert, Important Looking Pirates, Encore VFX, Patrick Fillion, and Gearbox Studio Quebec. Thanks so much, guys.